Hello everyone, welcome back to my series of videos where I'm solving each one of LeetCode's problems. I'm still on the easy ones. I've solved all of this. Well, not all of them. Some of them are like locked because I'm not a premium user. And I still have all of this installed. So let's go. Next one, isomorphic strings. What is this? Given two strings S and T, determine if they are isomorphic. Two strings S and T are isomorphic if the characters in S can be replaced to get T. Okay, so egg and add. Oh, I get it. So they need to have the same length. And let's say if we replace a G with something else, we need to also to replace the other G with that other something else. Oh, this is okay. I think I know how to do it in a very simple way. So let me just create a directory 205 isomorphic string code 205. Solution dot pi. And now let me just copy this. Return true. Always the optimist. And solution is isomorphic egg add. Okay, so what I'm going to do here is I'm going to create a string from the first. I'm going to iterate over the first string and create a string with numbers. So I'm going to replace it with numbers. So how shall I do this? So new string s representation is going to be a list of integers. It starts with this. Well, I can just, if I can see if the lengths are different. If length s different than length of t, then I can just return false because they need to have the same length. Let's assume they have the same length. So for and now I need a dictionary. Corresponding is a dictionary of string and integer. So for char in S, I can say that no, I'm not thinking straight. I was thinking of converting the string S into numbers, so E would be 1, GG would be 2. And then I would convert the same thing with the other string. So this would be 1 and this would be 2. And then I would try to see if I could replace both. I can. Okay, no. I was trying something different. Okay, let's iterate each character at once. So for char index in range length of s. So let's see. Char of s equals s char index, and the same thing for char of t. And now we can go for correspondence. And that will be a dictionary of string. So we'll check. Okay, so we'll check if char of t not in correspondence of values. We don't need the dot values, but I like to do it. If it's not here, then I will say that t corresponds to s. So a will correspond to e. And not values, so keys. And char of s not in correspondence of values. I can do that. Correspondence of char of t equals char of s. Else return false. In. So if let's just look at this again. So if char of t, let's say a, the letter a, is not in the keys, okay, let's say that a corresponds to e, but e is already in the value, so e already corresponds to something else. So okay, then we can't really do this. So return false. Otherwise, we just add it there. And then I think this is it. I think that if we go all the way to the end, we can return true. So let me see if this works. So char of t, char of s. A, s. A is not in correspondence. Okay, no, there's things missing. If char of t not in correspondence and char of s in correspondence, then there's a mistake. No. Yes, this is the mistake. Return false. Else, I was thinking the other way around. Hey, true. So what if we do egg x? Okay, so I want to see where x shows up. E, G, X. If char of if they not in correspondence keys, oh, I need more conditions. Or I think if I just do this, because char of t is in, or char of t in correspondence, and correspondence char of t is different than char of s. Yeah. So my initial plan was, let's just build a correspondence array, dictionary, and then create a string that is the corresponding string. And then let's compare string s with the corresponding string that was created. And it should be the same. But yeah, I changed my mind and then I just went this way. Let's just see if egg works. True. Okay, let's give it a shot. Yeah, it works. Hope you guys enjoyed it. See you later.